Alrighty. Hey, Bob. Hope you're going all right, man. And Moses is not with us this morning either. So, and now we have to wait because people are jabber-jawsing. Thanks. So, just the start of this topic, I won't have to say too much, one hopes. We remember that we've got our complex plane. I was going to say, who remembers what it's called, but it's right there in bold. Right, the Argand plane. You do need to make sure you've got your real axis is your X. I know last year some of you switched those around. Please don't do that, right? If you need to make a note, you've got your real, you've got your imaginary. And it is at this point where I would say if you haven't either got a separate book or separate pad paper or whatever to write down your summaries of things, hurry up and do it. Don't keep saying tomorrow. Get one of those A4 books or A5 books, from Woolies. They're like less than $1. Write your stuff down. Maybe I'll get them for you from my Powerball winnings of $8 from the 120. But like you think about all the little bits and pieces that we had from our functions stuff, and even now from your test, maybe you're going to write some notes down there because you will forget it as it comes along. And before you know it, when's our mid-year exam? Week 1, term 3, right? So little things that you just want to add and you go, oh yeah, summary. You will get a photocopy of some notes from the revision guides where they've got summaries of all the things there, but you know, it's nice for you to write stuff down as well. Notice, fancy R, you might not even be the E there. It might just be a fancy R with the Z. That is the real component of your complex number. And yes, that is the I. Look at that, fancy I. And anyone remember how I do my eyes? That's my I. Don't knock it. So simple things like that. And it means that we can represent any complex number. So A plus BI, we would go across here, A units, and up B. We've got the little Z with the bar across it. That represents our conjugate, right? Notice it's a reflection in the x-axis. Bang. Nice. So it's going to just go through and the other thing you can have, the conjugate being represented by a star as well. Just going to go through, and as much as I think, oh, good Lord, this is irritating to me, I do want you to draw these. I know, but when it comes later, there's things that this will help you later on to visualize. I know from previous years it does struggle. So look, can we do it algebraically? Absolutely. See what that looks like graphically. So if we look here, we've got Z1. So we've gone across 4, 1, 2, 3, 4, up 1 for the imaginary, and then we're adding on -1. So we've gone across -1 and then up 2. Notice it's tip to tail, like we did with vectors. And then from the beginning, so do you have to do it for every single one? No, maybe a couple, but just so you know. And even this stuff here, can you double check it using your calculator? Just get used to, where's your imaginary, all that sort of jazz. So 4A, I think you can do reasonably quickly. The only one that you might sort of go, could be 6, but there's no thingies there. Solve for Z, how would you plan on doing that? Algebra, how? Quad formula. So you're just, your minus B will be -2 take I, and so on. So 6, quad formula, just making sure that you're careful using the quad formula. You're then going to go on and even take care of the modulus, right? So that is representing the length of our vector. Okay, and how do we find that length? Our friend Pythagoras. So A squared plus B squared equals your length of Z. We're remembering a lot of this stuff? Okay. It's also, we're going to do stuff with the argument that comes in exercise 6C a lot. and your calculator will do it for you. But what I will do is I will replace some of these with letters rather than numbers, so your calculator will become useless. I know, mean. But how would you find this angle? How using trig? Right angle trig, opposite, over. No, hang on. So you could go over hypotenuse. However, you would be given, imagine if you had a complex number, so 3 plus 4i, you would just go, it's opposite over, adjacent, because they were the values that you were given. Is that too quick? Too much to picture? I think we're okay. And that's called the argument. Now, they don't do too much of that here. Simple stuff that they go on. I wonder if any of you remember how to find that on your graphics calculator. That could be the quiz. Well, your calculator will find the argument and will find the angle for you. It does it. So anyway, we'll see if you can find that. It then rolls on to these properties of modulus. Okay. It's up to you again how many of these questions that you have to do before you go, oh, seriously? To find the modulus, that is going to be the square root of 2 squared plus 1 squared. Good, not I, but 2 squared plus 1 squared, all square rooted. 3 squared plus 2 squared, all square rooted. How many of those do you have to do? What do you think the gist is with question 2? What are they trying to show you? What about the length of all of these? They will be the same. 3, 2, 3, 2, 3. So, up to you. I will have a chinwag about number 3 in maybe 10 minutes. not that you're going to be up to that, but just so you can do it and not stress about it at home. So I will shut up now, and you will begin with 4A and just working your way through, and you can be your judge as to how much or how little you do. Love you.